So I thought we would start with this in all of these lessons that we have in the consolidation workshop lessons course. I'm not too sure what to call this, but if you had a really nasty question in your exam,
pajama
obviously,
party. That's what it is.
yeah, pajama party. As if it can't be like a whole page of a question, like you can't send me something like that. But if you have a single sort of question that you really struggled with that you would like us to talk about as a class, please feel free to ask it in the first sort of 10 minutes of each of these lessons. We can go through it. So I know people might not have one ready for today, but from Thursday, just have a look through your exams and see if there was a question that you got wrong that you would like us to talk through, and we can go through it together. Okay, but one of my grade 9s did land up having a question, so let me just ask you guys, does anyone have a question that they had during their exam that they would like a little bit of clarification on, or to ask us to go through together as a class? Do you have one that's been bugging you? Sometimes you have a question that sort of haunts you weeks after you write the exam. You don't have to have one, just in case. Okay. Okay, so please go through your papers this afternoon and tomorrow. See if you can find a question that we can go through, and then we'll try and answer one or two in each of these lessons. Okay, cool. Let's jump into exponents. Before we jump into anything, let's just quickly go over our basics. Oh no, Paul, that's fine. It can be about factorization. That's totally fine. Do you have it with you? It can be about anything. Like the question can literally be about everything. Ah, Tiamo, that's so irritating. And Paul, if it's easier to say versus typing, just put your hand up for me so that I can unmute you. Okay. If you're typing it, keep on typing it. I will come back here as soon as I see it in the chat. Okay. All right. Okay, that's okay. And Paul, bring it for me on Thursday and we'll start our lesson with it, all right? I know like everyone's dealing with severe load shedding today. Okay, so before we jump into exponents, there's a few things that we really just need to know. And I know that this seems like common knowledge, but if we get these wrong, then we really mess things up quite badly. So first thing is when we're dealing with exponents, we have a base and we have an exponent, or you can call it power, or you can call it an index, any one of those words. Okay, but we have a base and then we have a power or an index. And so when we're working with exponents, it's really important that we make sure that our bases are the same as each other. So that's something that I'm going to say a lot over the next hour. So you will probably get bored of it, but I promise it helps when you start looking at some questions. Okay. Now, when we are in grade 10, we are expected to know all of these different laws and definitions. So I'm going to put them all together like this so that you can take a screenshot. But these are all the different laws and definitions that we need to know about exponents. Let's just quickly go through them. So we're going to kind of zoom through them, and then I'm going to go through a couple of questions for you, and then I'm going to let you work through some yourselves. So the first law, law 1, is when we're dealing with multiplication. So multiplication means that I'm multiplying two things, but my bases are the same as each other. So here my bases are both x, and when my bases are the same, then I'm allowed to add my exponents, okay? So if I had x to the power of 3 times x to the power of 4, my bases are the same, which means that's going to be x to the power of 7. All right. When we're looking at division, so I'm dividing x to the power of a over x to the power of b. My bases are the same as each other. And when that's the case, then I'm allowed to subtract my a from my b. Okay, so if I had a to the power of 7 over a to the power of 2, that would be a to the power of 5. Cool. if I had a to the power of 5 over a to the power of 7, what would that be equal to? Who can give me the answer for that? Okay, so Portia's saying -2. So I've got a to the -2. Do we like dealing with negative exponents though? Are negative exponents something we enjoy? So a to the -2 is 100% right. Good, Xiangmo. Yes, yes. Okay, I'm just going to write this so I have a little bit more space. A to the power of 5 over a to the power of 7 would be a to the -2, which is the same as writing a to the power of 2 at the bottom. Okay. Hello, where to? Hi, how can I help? I think maybe you were going to answer that question.
I think you wanted to answer.
Yeah. Okay. Law 3, when we have a power to a power, so in this case, we are saying we've got x to the power of a to the power of b, and when we have a power to a power, we multiply them. So if I had x to the power of 2 to the power of 3, I'm going to multiply those two together, and I'm going to get x to the power of 6. All right. Distributive law uses the idea of a power to a power, but we have to use it in a slightly different way. So we've got x to the power of a, y to the power of b, and that's all to the power of c. And so we distribute the c into both of those. So it's the same idea as a power to a power, except that I have to use it more broadly. So let's have a look at what that would be when I have some extra numbers. If I have x to the power of 2, y to the power of 4, and all of that's to the power of 3, then that's going to be x to the power of 6, y to the power of 12. So we're going to multiply the 2 by the 3, and we're going to multiply the 4 by the 3. Okay. Cool. Next one. When we have anything that is to the power of 0, it's going to equal 1, and I mean anything. So if I have 2x, y, z, and all to the power of 0, that's going to equal 1. What is this going to equal? What would -2x to the power of 0 equal? What's that going to equal? It's not going to equal -1. It's not going to equal 2. There we go. It's going to equal -2. Good. Okay. So this x to the power of 0, that's the only thing that's going to equal 1. So that's going to be -2 times 1, which gives me the answer of -2. Okay.
I'm not sure if Kando wants to ask a question.
We can try again. I think the network might be kicking her off and on. Ah, there we are. Hello.
Hello, ma'am.
Hi, how can I help?
I have a question on law 1.
Okay.
May I ask if the base are not the same, what would you do? I don't get it because here the base are the same, so you add the exponent. What if the base are not the same?
Okay, so if I had x to the power of 3, y to the power of 2 times y to the power of 3, I'm only allowed to add the ones that have the same base. So I would then say that that's equal to x to the power of 3, y to the power of 5.
Oh,
Make sense?
If the bases are not the same, you do not do anything with the base, but what you use are the exponents.
Exactly. So when the bases are the same, whichever ones have the same base, we can add the exponents of the ones that have the same base.
If the base are the same, you only take one base.
Yes, exactly.
Okay, thank you, ma'am.
No problem. Okay, and then our last one over here is our negative exponents. Okay, and these are the ones that really mess with our heads. When we have something to the power of a negative, like we did over here, we had this a to the -2. That's the same as writing 1 over x to the power of a. Okay, so if I was writing this in a slightly different way, if I had x, let's say I had 1 over x to the power of 4, that's the same as me saying x to the power of negative 4. So when I'm moving it up or moving it down, then my power changes. Okay, another thing that I want you to write here is that if I have 2 over x, and that's to the negative 1, that is equal to x over 2 to the positive 1. So when we're dealing with negative exponents and fractions, if we flip the fraction, then our exponent goes from negative to positive if we flip the fraction. Okay, cool. If you would like a screenshot with these additions put in, please take one, and then we're going to move down.
Time for you to shine, shine, shine. Take the screenshots. It's good for you. It has all the laws, guys.
All the laws.
I would have this, you know, like either at the top of, like when I sleep on my bed and I look up and I'll see all these laws, or I put it
Going
like
to
on
sleep
my
just
door.
thinking about maths.
Yeah.
Oh.
It's a good thing I love exponents. I didn't want to forget.
Okay, guys, I'm going to zoom through these ones. So I'm going to talk you through these ones, but I'm going to go through them quite quickly. And then I'm going to give you time to think about the other ones that we're going to do later. Okay, so don't panic. I'm just going to talk you through these ones, and then I'm going to give you time to do some yourselves. If I'm looking at this question over here, I can see that I'm multiplying everything. Everything has the same base. They all have a base of x, okay? This one doesn't have an exponent, so if it did have an exponent, it would be to the power of 1. So I'm allowed to add all of those exponents. So I'm going to have x to the power of 2 plus 3, which is 5, plus 1, which is 6. Okay, so all I'm doing is because they have the same base, I'm keeping that base and I'm adding my exponents. Okay. Are we feeling okay with that? Hopefully that this isn't too scary at this point. All right. Next one. We're now looking at law 2. So now I'm looking at division. Okay. When we're dealing with division, sometimes it helps us to write it out the long way. So if I wanted to write this out the long way, I've got 2 A's, a B and a C at the top. And at the bottom, I've got 2 AC. Now, because of that, I can see that my 1A cancels with my 1A and my C cancels with my C. And so I'm left with AB at the top and 2 at the bottom. So it's really important that we keep things, if they are on a numerator, that we keep them on the numerator. And if they're a denominator, that we keep them on the denominator. Okay, another way to look at this is we're looking at ones that have the same base. So over there, I've got 2 minus 1, which is going to give me 1. And if I look at my B's, I've just got a B, and those C's are going to just cancel each other out. Okay, so that's looking at what this would look like with division. Cool. Are we all happy so far? Can you give me an idea of if we're happy, sad, somewhere in between? Okay, cool. Thank you. Hearts and thumbs up. I like it. Good. Excellent. So,
Juliet has her hand up.
oh, hello, Juliet. How are you?
Hi, ma'am. I'm good, and you?
I'm good. How can I help?
Ma'am, I wanted to ask an example too. Is it important for us to keep the power as 1 in this in the
No, you don't have to have that
answer?
1 there at all. You can literally just write that as AB.
Okay, ma'am. Thank you.
Sure, no problem. Okay, let's have a look at example 3. So now example 3, it's also using law 1. Now we just have to be wary of which ones are the same base. Okay, so we've got x, and we've got x. I'm going to also highlight its exponent. Okay, and then we've got our y's. We've got y squared, y cubed. So if I was working this out, I'd look at my x's first. I've got x to the power of 2, 3, 4. Then we look at our y's. 1, 2, 3, 4, 5, 6. Okay, so this is when we say they have to have the same base. So we look at all of our x's and we add up all of their exponents, and then we look at all of our y's and we add up all of their exponents. Cool. Here we have another situation where we've got fractions and we're multiplying them together, okay? When we're in this, there's lots of different things we can do. We can simplify each fraction, but what I find generally to be the easiest thing is multiply your numerator, and then this works for most questions, and multiply your denominator, and then see what you can simplify. Okay, so if we're just looking at that purple at the top, I've got 1a, 2 3a's, 4a's. Okay, so I've got a to the power of 4 at the top. Then we look at our b's. I've got 2b's, 4b's, 5b's. B to the power of 5. All over a, b, c. So if that's my first step to get to this point over here, what would my answer be? Who can tell me what my answer would be to this question? So I've got a to the power of 4, b to the power of 5 over a, b, c. What is my answer? Oh, it's close, but you're in my trap. Also in my trap. There we go, Beverly. That's what I like to see. Juliet, hello. Are you giving me my answer?
Oh, yes, ma'am. I wanted to give you an answer.
Okay, I'm ready.
It's going to be a cubed b 4 b to the power of 4 over b. Over c.
Yes,
Over
nice
C.
job. Excellent. Well done, well done, well done. Okay, so now we have to be super careful here that the c stays at the bottom because it wasn't ever at the top. It was always in the denominator, so it has to stay in the denominator. We have to be really, really careful with things like this because if we make mistakes, they're going to give us no marks. Okay, so these are small little things that we need to be careful with. Cool. Okay, I'm going to go on to our next one. Okay, sometimes we can be given questions like this where we're just dealing with numbers and we're going to act exactly the same way. Our bases are the same, which means we're just allowed to add our exponents. So that just becomes 2 to the power of 9. Okay, our bases are the same, so we just add our exponents. Happy days. We don't have to overthink it. We don't have to write this huge big number. We can just add our 2 exponents together. Oh, I have power. How exciting. Okay. Sometimes we get given questions like this where there's a divide sign instead of a fraction. So why did we put the denominators together? In this one. Maybe you're meaning in example 4. So when we multiply fractions, you always multiply everything together. So you're saying a times b times c, and a times b times c is abc. So if I had like 1 over x times 1 over y, that would be 1 over xy. Okay. Okay.
I think Teacher Jenny's slide is on. Like, let them be like, sorry, this is so random.
I'm so excited to have like lights everywhere.
I couldn't hold it in.
And power.
You know,
It's good. It's a good moment. Okay. Let's have a look. When we have it like this, and the first thing we want to do is we want to write it as a fraction. Okay, so we want to write 3y to the power of 6 over 6y to the power of 4. Then we look at our numbers. So I've got 3 over 6. If I'm trying to simplify 3 over 6, I would simplify that as 1 over 2. Then we look at our y's, y to the power of 6 and y to the power of 4. 6 minus 4 is going to give me y squared. So we can write that as 1y squared over 2, or we could write that as y squared over 2, or you could write that as a half y squared. All of those would be right. So it doesn't matter which way you write that, all of those would be correct. So Sipo, how can I help?
Good evening, ma'am. I wanted to ask, can ma'am please re-explain example 6?
Okay, which part of it are you feeling confused by?
After when ma'am written the whole thing in the fraction, now I'm a bit lost when it gets there.
Okay, so when we get to this point over here, all we're doing is we're first looking at our numbers. So we're saying, what is 3 divided by 6? And 3 divided by 6 gives us a half. Okay, and then we have y to the power of 6 over y to the power of 4. So we're just using our division rule where we subtract our exponents. So we're saying 6 minus 4, which would give us y to the power of 2. So you're welcome to write it like that. So you can definitely write it as 1 over 2 and then y squared. Where that sometimes gets a little bit nasty is sometimes we have to have exponents on the top and things on the bottom as well. So what I recommend you get into the habit of doing is rather writing it like this. Even though it may look messier to you, when we start having variables on the top and in the bottom, then this way will be your friend. So try and see if you can get this way from here. Okay. Cool. Let's see if I'm going to do one more with you, and then I'm going to give you a quick brain break, and then I'm going to let you try some of these by yourself. Okay. When we're in a situation like this, where we've got this complicated numerator and denominator, we're wanting to sort of break it up and make it easier for ourselves. So we start by just looking at our numerator. Now, when we look at our numerator, we want to start with our numbers, okay? So we've got negative 4 times 6, and that's going to give us negative 24. Then we look at our variables. We've got 1x over here and 3x's over there, which means we're going to have 4x's. And we have 3y's over here and 2y's over here, so we're going to have 5y's. We're going to divide that all by our denominator. Okay. Then we look at it sort of step by step from here. So first look at your numbers. Negative 24 divided by negative 3 is going to give us positive 8. Again, you can write it as a whole number, or you can write it as your numerator. Okay. Then we've got x to the power of 4 over x to the power of 2. So 4 minus 2 is going to give us 2x's. And here we've got y to the power of 5 divided by y, which is going to give us 4y's. Okay. On a scale of 0 to 10, how ready do you feel to give some of these a try by yourself? Super Setu, how can I help?
Afternoon, ma'am. I just wanted to ask, what if your 4 in your numerator is a positive 4?
Okay, so then this would be positive 24 x to the 4y to the 5 over negative 3x squared y. And so then my final answer would just be negative 8, because I would have a positive divided by a negative.
Oh, thank you, ma'am.
No problem. Okay, I'm seeing some high numbers here. I'm seeing 7s, 8s, 9s and halves. I saw some 10s. I feel like that means that you're ready to give some a try. Okay, we're going to do a very quick brain break. I did not realize how easy it was until I gave it to grade 9, so I would like to apologize. I did not think it was this easy. But anyway, let's do a quick brain break, and then I'm going to give you some questions to try by yourself. Okay. So, a man was outside in the rain without an umbrella or a hat and didn't get a single hair on his head wet. Why?
We can do this, guys. They're grade 9s.
No, you see, guys, they just know it. How do you guys just know these things?
Oh.
Yes. He is bald. He's bald. He doesn't have hair.
But how do you know that? I mean, I normally don't read riddles, and I didn't know this answer, actually. It took me a while.
I don't know how they get it so quickly, honestly. I really don't. Guys are too quick.
Definitely are smart.
Too smart for us. Too smart. Okay. Let's give some questions a try. Let's see how you cope. I don't want to be too nasty too soon.
Did you hear her? She doesn't want to be too nasty too soon, meaning that soon enough she'll get there. Like a chunk from our own saliva.
Okay, I'm going to be a little bit kinder to you, and I'm going to get rid of this guy. Just for the moment. I'm going to get unkind very quickly. But for the first one, I'll be kind to you. I would like to know what my answer to this question is. You should. It is definitely a calm before the storm. It's going to get hella spicy. What is my answer here? Try and do it step by step. Look at what your numerator is going to be. Look at what your denominator is going to be. And then try and simplify from there. Sibongo Kukle, can you tell me what to do?
You multiply the x, the 6x and the x to the power 3 and the y to the 2.
Okay, so what's that going to become?
It's going to become 6x to the 4 and y to the 2.
Perfect. Okay, what's my denominator going to become?
3xy to the 2.
Beautiful. Okay, what is my final answer?
2x to the 3.
2x to the 3. So just like this. Nothing else.
Yes.
Beautiful. You didn't fall for my trap. Well done. Nice. And I like the confidence. 100%. Good work. Excellent.
Thank you.
So when we have a look at this question, the first thing we want to see is we see the 6 and the 3. And 6 divided by 3 is going to give us a 2. Then we've got 4 minus 1, which is going to give us a 3's. And our y squareds are going to cancel. So we're just left with 2x cubed. That's all. Nice job. Hopefully we are making some progress. Let's see how you deal with my next one.
At the end of this, you guys will be definitely know all the rules, the 1 law, 2 law, 3 law, 4.
You will be exponents.
Wow.
Yeah, exponent brain buffs.
Yep.
Let's do this one. Think about something we spoke about right in the beginning of the lesson that will help you. Because there's a very quick way to do this, and then there's a very long way to do this. Let's see if anyone manages to remember the quick way.
If you did take a screenshot at the beginning of this lesson, you'll definitely be able to do this question.
Yeah, if you have a screenshot, you will find the very quick way of doing this question. I promise it takes a bit of time, but it'll happen. I promise. Beverly, can you tell me my answer?
Is it ready for us?
Hi, ma'am.
Hi.
So I got, well, what I did was I flipped the denominator and the numerator
Beautiful.
so that 2y was at the top and then the other one was at the bottom.
Excellent.
And then I didn't know what to do after that. So,
Okay, but that was a great start. I like it. Well done. That was half the battle. Good job. Okay, so when we see we have something to the negative and we're dealing with a fractions, I want your brain to think I have a negative exponent, so I should flip the fraction and then I'll have a positive exponent. Okay, so as soon as you're given a fraction and it has a negative exponent, flip the fraction and make it positive. Because now we've just got 2y over xy squared to the power of 1, which is the same as just having it as is. Okay. Sorry, my cat is like attacking something. I'm just going to go and move her. We're just going to go on a slight walkabout, guys. Okay, no, what are you doing? All right. Sorry about that. Now we can simplify. So we've got 2y at the top, and then we've got xy squared at the bottom. If I had to write this out the long way, I would have 2y at the top, and at the bottom I would have x, y, y. All right? This y can cancel with that y, which means my final answer would be 2 over xy. And I see a couple of people got there, which is great. And hopefully we are feeling a little bit more confident with some exponents so far. Good. Nice. Let's give another one a go. I want to find one which is like combines a few things. I think I'm going to have to do a bit of scrolling to get to what I'm wanting to get to. Oh no, this is nice. Again, with this question, you've got two different ways of doing it. Both would probably take a similar amount of time. But it's up to you how you want to deal with it. What happens to the 1? So anything to the power of 1, like if I had 5 to the power of 1, that's just the same as saying 5. So we can just ignore it. It doesn't affect our question. Yeah. Cool. So there are two different ways to go about this question. I'm happy with either. Different minds just think differently. So some minds will think of it in one way and some minds will think of it in another way. Let's see how your mind thinks about it. I'm very curious. See who thinks in the same way that I think and who thinks in the same way that others think. Okay, so Sino, that's a great start. I can't leave my answer there. Yes, yes. But Melo, we always want to leave our answer with positive exponents. Good for asking that question. Well done. Tunnel, where to? Are you going to give us our answer?
I can try, ma'am.
Okay, I'm excited. Tell me what you did.
I got a to the exponent of 4.
Okay.
1 over b to the exponent of 6. And
Okay.
1 over c to the exponent of 2.
Okay.
1
so
over
what
c to the exponent of 2.
What you've written is great. We're going to write it in a slightly different way so that when they get a bit more complicated, they don't sort of mix with our brains. But what you wrote is perfect. You wrote it in a really good way. Okay. I'm just going to write it in a slightly different way and you'll see why now. So I'm going to show you the two different ways of doing this. The one way is by doing our distribution. Okay, so we saw -2 times -2 gave us +4, which is what you did beautifully there. Then -2 times 3 is going to give us -6. Okay, so now what Tunnel Way to was like, okay, if it's -6, I need to move it down, which is the right thought. Okay, I'm just going to do that in 2 steps. So I'm going to write that as b to the -6. Then I've got c to the power of 1 times -2. So that's going to be c to the -2. When we get to this point over here, we need to think that's got a negative exponent and that's got a negative exponent. If it has a negative exponent, we want to move it down. So we're just going to do that in one step. We're going to make a fraction. So we're going to keep our a to the 4 at the top. And then at the bottom, we're going to write b to the power of 6, c to the power of 2. Okay. So what you did was beautiful. This is just a different way of writing it so that it works a little bit more cohesively. That's method 1. Did anyone do it a different way? I'm curious to hear if anyone did it a different way.
It looks like Habiso did. Do you want to raise your hand, Habiso?
Yeah, if you guys did
Oh,
it a
you're a
different way,
bit
let us know.
shy.
Chuck that hand up and we'll chat.
Hey, Habiso, I saw your hand go. Okay, Beverly is on.
Beverly, tell me how you did yours.
So, ma'am, I put everything in brackets first, like separately. So I did 1 over a to the power of -2 in brackets to the power of 2.
Okay.
And then
Okay. So Beverly, what you did is great. It's the same sort of thing as Tunnelware 2. I'm going to take what you did and I'm just going to write it in a slightly different way. But the idea behind what you did is beautiful. Okay. So I'm just going to write that idea in a slightly different way. So what Beverly did was she first looked at these and thought, well, hold on, a to the -2 is negative. So I'm going to first move that down. Okay. So what I'm going to do is I'm going to, oh, that's not what I was wanting to do. I'm going to break this dude up. Let's just rewrite our question. And I'm going to make that a fraction right in the beginning. So I'm going to write that as this is a negative. So I'm going to move it down to the bottom. So I'm going to have b cubed c over a squared. So Beverly, you wrote it as a separate fraction with brackets and a power, which is great. This just kind of skips a couple of steps along the way to make our life easier when the questions get a bit bigger. Okay, so all I'm doing is I'm moving that down to the bottom because it's a negative exponent, and all of that is to the power of -2. But we've just learned that when we have a negative exponent in a fraction, we're allowed to flip that fraction and we're allowed to make the exponent positive. So now we can say, well, actually, that's a squared over b cubed c all to the power of +2. And then we can distribute that 2. So a to the power of 4 over b to the power of 6, c to the power of 2. We get to the same place. So it all depends on your preference. You can write it as you like. I know that our tendency to break it up into separate sections feels easier, but when the questions get bigger, that can sometimes really mess with us and it can make us make silly mistakes. So while this may look more confusing at the moment, see if you can try and bring things together when we're working through these tonight, because it will help you later on down the line. Yes, so Soma, that's exactly the same thing. So that's actually what I've done here. It just doesn't look like it. Ooh, this a to the 2 over here, that's the same as me writing as 1 over a squared. That's the same thing. Same idea. It's just written as a combined idea. Nice job, guys. Very different trains of thought, which I like. How mean do we want to be, Linda?
Let's do it the rib one. The ribs. Because I feel like ribs. So.
Like ribs.
Yeah.
Let's give this one a go. Let's see how this goes. Don't fall for my traps. There are many, many traps that I've set for you here. Don't fall for them. I can count at least 2. Just looking at this question, I can see 2 big traps. So if you want to check things along the way, you're welcome to put them in the comments and we can talk about them. Or if you want to just get some confirmation about something you've done, you're welcome to put your hand up and we can chat about it. But don't fall for my traps.
I was so jealous of your tea. Now that you finished, I'm like, we're in the same progress.
Oh, I'm so sad. It's all gone.
I know. Oh, gone now. That
All
is 20
gone.
minutes left.
But
You
I
have
have
survived.
power. I have
You know?
power.
Now you can make coffee.
I can make tea. I can make dinner. Guys, stage 4 and stage 6 are no joke. I feel like I just never have power. I'm just constantly and I don't charge things when I'm supposed to charge things. I'm not made for load shedding.
Because it's not normal to charge things. Yeah, in South Africa, we just, we charge whenever because we didn't know we're gonna have stage 6.
Stage 6 is a different thing, eh? That's a biggie. I know it's coming back at 10.
Like the audacity, they even have to cut us that much. It's too much.
Too much. I'm worried about the silence of this question, guys. I'm worried that it's made some people just panic.
Habis is working.
Okay.
Is working.
Okay.
I see them.
Okay, good. Thank you. I think I might talk you guys through this one. I think it'll be easier to explain, but please feel free to put your answers in the chat when you have answers. And remember, exactly, silence equals panic. That's exactly what I was thinking. But remember that I don't mind if your answers are wrong, as long as you're trying. Juliet, we never just sit back and just cry. We always try. No cry, try. Oh no,
Emmanuel. Guys, step by step. Remember, you get marks to even get away with one step. With the first step, you already have 1 mark.
Guys, there is a lot going on. I'm going to show you some ways to try and make this a little bit easier. Okay. Do you need more time? Does anyone need more time? Sure.
Tiamo. Oh.
Oh, that's a big
so
number.
Excited. I saw Tiamo's hand. I was like, wow.
No, they were saying I need more time. Okay. All right. Let's try and tackle this dude. So, my recommendation is always deal with the numerator and then deal with the denominator. So, let's look at this dude over here. You don't have to do this, okay? But when we have things that are squared, what I find makes life easier is for us to just write it out twice. It takes a whole variable out of the situation that we don't have to stress about. Okay, so I would write that numerator as -3, 3x, 3x, okay? Because my 3x was what was being squared. Then this is also being squared. So I'm going to write -3x squared, -3x squared. And all of that is over 3 to the power of 6, x to the -2. Okay, that's how I would start this. You don't have to do it this way. It just makes our life a bit easier. Then let's look. Remember, we spoke about this a long time ago, and we spoke about this when you were in grade 9. So I don't know if you remember, but remember signs, numbers, variables, SNV. Okay, signs. Let's look at our signs. We've got a negative, a negative, and a negative. What are 3 negative signs going to give me? Is it going to be a negative or a positive? Come on. Thank you, Beverly. Thank you, Sino. Good. It's going to be a negative. Okay. Now we could multiply those 3's, but let's use exponents because we're doing exponents. So I've got 1, 2, 3, 4, 5 3's. So I've got 3 to the power of 5. Then let's look at our x's. I've got 1, 2, 3, 4, 5, 6. 6 x's. All over 3 to the power of 6, x to the power of -2. Okay. Then let's try and think about what this means. I've got this x to the -2 at the bottom. In order for that x to the -2 to be positive, I've got to move it up to the top. Okay? Just give myself some more space. So I'm going to have -3 to the power of 5 over 3 to the power of 6. and then x to the power of 6 times x to the power of 2, because I'm moving it up so that it becomes positive. Now let's think about what this means. How can I simplify this x to the power of 6, x to the power of 2? What is that going to become? What is x to the power of 6 times x to the power of 2 going to become? Good. X to the power of 8. Good, good. Okay. Now let's think about what these 3's are going to become. So my negative sign is just there. I have a negative, okay? Then I've got 5 3's. 1, 2, 3, 4, 5 3's, x to the power of 8, all over 1, 2, 3, 4, 5, 6 3's at the, ooh, 6 3's at the bottom. So if I cancel them, I'm going to say cancel, 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 and I'm left with 1 3 at the bottom. And so this is going to be written as negative x to the power of 8 over 3. How glorious is that? Do we have anyone who even got close? Let's try and break up the steps. Did anyone manage to get to this point over here, the negative 3 to the power of 5, x to the power of 6?
This was like a charm, guys. It was a charm. Tiamo on the line.
Tiamo, oh, just letting us know. No, but remember, if I can't make it look easy, then I'm really not doing my job well. So don't panic. It's my job to be able to do these things. It is not your job to be able to do these things yet. You have to get there. It takes time. Okay, got some half marks. That's not bad. If you did it a slightly different way, so if you didn't write it out the long way like this, now lots of people try and avoid this long way because they think it takes longer, but my advice is in maths is I'd rather it take longer and get it right than try and do it quickly and get it horribly, horribly wrong. So sometimes taking a little bit longer is okay. It's the same idea as if you're in your maths exam and you're not finishing, don't panic. I would much rather you be confident in the questions that you've done and know that you've got those marks in your pocket than try and scramble and rush and finish everything and do everything poorly. Sometimes you have to accept you're not going to get through everything, and that's okay. All right. I'll show you a slightly different way of looking at this as well. Therefore, how can I help? Oh, okay. Yes, Emmanuel slow and steady wins the race. Exactly. So another way of looking at this is when you have, I'm just going to write it over here. So we've got this negative 3x squared, negative 3x squared to the power of 2. Another way you could have looked at this is you could have dealt with it with numbers, okay? So you could have said, cool, I've got negative 3. I'm just looking at my numerator here. Then I'm squaring my 3, so that's going to become 9, and I'm squaring my x, so that's going to become x squared. I'm squaring my negative 3, so that's going to become 9, and my x is going to become x to the power of 4. And then you land up multiplying all your numbers. You could absolutely do it that way. There is no harm in doing it that way. It's just that sometimes our numbers get a little bit fuzzy and we make some mistakes. Okay. Cool. Totally fine to do it that way. 100% fine to do it that way. And you would get marks along the way if you did that. So if that's the way your brain wants to think and that's the way it sees it, please do it that way. You must do the way that you are most comfortable with doing. Awesome. What if they give different numbers? So we shouldn't have gotten different numbers. Let's try and have a look here. Let me just grab my calculator for a second. So, because these are not numbers that I would just know in my brain. So we've got 9 times 9 times 3. So what this would become if you had done it this way is you would have negative 243 x to the power of 6 all over 729 x to the power of negative 2. And then you would have been able to divide that and you would have still gotten negative 1 over 3. And then that x to the negative 2 would have moved up and you would have had x to the 8. So please do which way you're happy with and which one you're comfortable with. That's the one that I want you to focus on and do. In maths, it's never about just the answer. Maths is literally all about the process, and everyone's brain thinks differently. So you must do the way that your brain thinks and the way that your brain is comfortable doing it. Okay, let's try and fit in one more question before our time runs out. Let's do this one. Okay.
You're so kind. I wanted them to flip it because they had to know.
I know, I felt like that they would be. Should I just be nasty? Let's just be nasty. That's fine.
You know,
it's fine, Yolanda, you're right. You're right. Let's just let them suffer. If you guys struggle, this is not my fault. This is Yolanda's fault.
It's on me, guys. On me.
I was trying to be nice. I was trying to give you an easy way out. And she was like, no. They must do it the long way.
And you can change everything. One trick that you need to know. That's it.
Think of some delicious chicken.
Yeah, ribs. When is end of month? I can buy ribs.
It's soon. Guys, when we see a division sign with fractions, what do we think? What 3 letters do we think of when we see a division sign with fractions? Good. We definitely multiply. We definitely flip. Good. Yes, Georgia. KFC. Keep, flip, change. Keep, change, flip. Guys. Keep, flip, change.
That's the only thing.
Good. And remember, when you do that change, when you're doing KFC, that negative doesn't become a positive because you're doing it in a different way. So you're doing KFC, you're not changing the negatives and positives. You will still have to move that at a different time. So don't fall for that trap.
They're really doing well. Keep going, guys.
Just going to write the first step up here. Just because of our time. Okay, so all I've done is my KFC.
Last question of the day, guys. Let's do this.
Yeah, after this one, you can turn your brains right off.
You know, I could do it and then it goes to sleep.
Yes. Okay, so now when we're at this point, we want to move the negative exponents. We want to move them either to the top or to the bottom to make them positive. Let's see if we get some answers. Okay, I'm going to start going through it just because of our time. I don't want to rush you, but our time is fleeting because this hour disappears on us. Okay, so the next thing I'm going to do is I'm going to move these negatives and I'm going to move them up. So I'm going to have 8m to the power of 2, m to the power of 3n over 9n squared. And you could do this in one step. You could say that's m to the power of 5 over 3m to the power of 4n times n over 16m cubed. Okay. Now that's going to simplify down. I'm going to multiply my numbers together and I'm going to basically do my numerator and my denominator. So 8 times 3 is going to be 24. Now I'm going to look at my m's all together. So I've got 2, 5, 9 m's, and I've got 3 n's. And then I've got 9 times 16. What's 9 times 16, guys? My brain's not here today. My brain's on holiday with you. 144. Thanks, guys. 144. And then I've got m cubed n squared. So now when we get to this point here, now we can just simplify things. So we've got 24 and 144. So we're going to need to simplify that down with numbers, but we can get there now. Let's look at our letters. Okay, so we've got m to the power of 9 over m to the power of 3, which is going to be m to the power of 6, and n to the power of 3 over n to the power of 2, which is going to be n. And I'm just going to simplify these numbers up here to make my life a little bit easier. We're going to land up with 1 over 6. So you can write it like that, or you could write it as 1 over 6m to the power of 6n, or you could write it as m to the power of 6n over 6. All of those would work fine. Do we have anyone who landed up getting this one right? How did this one go? Or at least some of the way, like some parts of it. Yes! Oh, nice job, guys. Awesome. Awesome. And if you didn't get it right, I hope you were able to get some parts of it and you're feeling a bit more confident. And well done for being here on a holiday, guys. I know that's tough and I'm so proud of you for being here. We're going to do a tiny little bit more of exponent work on Thursday, and then we're going to jump into some simultaneous equations. It's going to be fun.
Beverly says it's too easy when they do it with Teacher Jen. I agree.
I wish that I could just go into your brains during your exams. So like you could look at a question and I will just sit there and I'll be like, Beverly, look at your variables. And then you would think, okay, yes, I know what to do.
And also, I'm sure they hear your voice whenever they're writing a test. They will be like, Teacher Jenny will be like, it's a trap, don't do this, it's a trap.
And I hope you do. I hope that's how you look at your maths questions.
Yeah.
I'm not falling for the trap.
I'm not going to fall for this trap. It's not in me. Never.
Good. Night, guys. I hope you have a lovely evening and good holiday. We'll see you on Thursday.